Red blood cells are packed with hemoglobin, an iron-containing protein molecule that transports oxygen. Each red blood cell is estimated to hold about 280 million hemoglobin molecules. And each hemoglobin molecule can bind up to 4 oxygen molecules. Affinity is the term used to describe hemoglobin's ability to bind oxygen. Once one molecule of oxygen is bound, it's easier for hemoglobin to bind others. This is called cooperative binding. Capillaries deliver oxygen and nutrients close enough to individual cells for the diffusion process to work. Outside the capillary, cells are at rest, and so they don't require much oxygen. Oxygen partial pressure there is at about 40 millimeters of mercury, only slightly lower than it is inside the capillary. Hemoglobin molecules react accordingly, releasing only one of their 4 molecules of oxygen. When a person is active, cellular respiration increases. More oxygen is used to make energy. As a result, there is an oxygen deficiency in these tissues, and the partial pressure of oxygen falls. A typical partial oxygen pressure in this situation is about 20 millimeters of mercury, which would be substantially lower than within the capillary. Hemoglobin responds to this situation by losing its affinity for oxygen and releasing about 3/4 of its load. These oxygen molecules diffuse out through the capillary walls and into the tissue cells. Also, the concentration or partial pressure of carbon dioxide, a waste product of cellular respiration, has increased in the tissues outside the capillary. This increases hemoglobin's affinity for CO2 molecules, and it binds them in place of the oxygen it's given up. The red cells leave the capillaries and travel through a series of venules and veins back to the heart, completing the systemic circuit. From the heart, the deoxygenated blood is pumped to the lungs. In the lung capillaries, hemoglobin loses its affinity for carbon dioxide, allowing the CO2 molecules to diffuse into the lungs. This happens because the partial pressure of carbon dioxide in the lung is lower than it is in the capillary. At the same time, partial oxygen pressure in the lungs is significantly higher than in the capillary. This pushes oxygen molecules to diffuse from the lung to the capillary where hemoglobin binds them. From the lungs, the oxygenated blood returns to the heart, where it will be pumped again throughout the body to supply tissues with the oxygen they need for respiration.